All right, so our objective today is to understand how to solve age problems using a system of equations That's number one. Number two, we're going to learn how charts can help organize data from a word problem. So this is actually a technique that I'm going to go over today that sometimes the chart just defines variables. Sometimes the chart actually produces equations that we can write our equations from and use as our system. So it may be something you haven't seen before, but it's a great way, especially in age problems, to define all your unknowns. So let's talk about what is a chart. So a chart is a way to organize data when two or more unknowns are involved. Okay? So every day I'm going to kind of share a chart with you and most of the problems, and I'm going to show you how it kind of alters for the particular kind of problem we're working on. So our chart is only going to be focused in on, for age problems, how do we define people's ages? Okay? And we're going to use those definitions to create some equations based on what we read in our problems. All right, so when we're dealing with age problems, there tend to be two or three people, and we have at 2 or 3 time frames. So I'm going to give you a little idea of what this looks like. So here's some of the things you have to be cautious when you're dealing with age problems. You have to read super carefully. And you need to understand what words mean now, what words mean the past, what words mean the future, and so on and so forth, okay? That's going to go help. So here's what my chart normally looks like. I take my people, and I write them vertically. Every one of these, well, I can't say everyone, but most age problems are concerned about how old somebody is right now. So what we have is a column called age now. That's the place where we're going to put our variables, because that's what we're most of the time going to be asked to solve for. If we can get down to that, then we can get to the other ages super easily.
What does it say after 2 or 3, the second one?
People, 2 or 3 time frames.
And then,
So then we're going to have, one or more columns in which we're going to have age at different times. So the other times we're talking about could be the future. And if I'm asking you what somebody's age is going to be in the future, if you know their age now, what are you going to do with the amount of years they tell you you're going to go in the future? Trent? You're going to add. So you're going to see adding going on when you're talking about future ages. The other kind of age you could be dealing with is a past age. So what are you going to do with the amount of time in the past in relationship to how old the person is now? Tyler B? You're going to use subtraction. Okay, oops. It's not very nice. All right? And we're going to get, of course, have a system because there's two people, and we're going to be able, we have to write two equations when we have two unknowns. We can't solve an equation with one equation with two variables in it. It's impossible. So we are going to always, the number of variables dictates the number of equations we're going to have to write. Okay? So again, we have to pay attention to the verbs to tell whether they're talking present, past, future. Justin Pratt? Okay. Okay, so let's try one of these. Unfortunately, you do have to write it down. All right, it just blitzed out on me. Here we go. First problem, oops, directions are just going to ask us to solve. And we have Carol is twice Linda's age. In 6 years, the sum of their ages will be 30. How old are they now? Okay. So Carol, is twice Linda's age. In 6 years, the sum of their ages will be 30. How old are they now? So let's go ahead and see what the chart looks like. Who are the people involved in this problem? Carol and Linda. We always talk about age now. And that's where we're going to get our two variables. I'm going to use C for Carol's age and L for Linda's age. That makes sense. Now, did they talk about their ages at a different time in this problem? Trent. Okay, so when I make my next column, I'm going to write age, and I'm going to be very specific. In 6 years. So if Carol is C right now, how old will she be in 6 years? Yeah, you guys told me I'm going to add, so I just take her current age and I add the 6 to it. And then what would Linda be? L plus 6. Okay, now these are not equations, right? These are just definitions of the people's ages at different times. Then when we read the problem, we're going to go back and say, oh, when they're talking about now, I got to use C and L. Oh, when they're talking about their ages in 6 years, I'm going to use C plus 6 and L plus 6. Okay? So let's go to the first equation. And the first thing you need to focus in on is the verb. What tense is that? Present tense. So that's now. Okay? So that means we're going to use these definitions of their ages to translate that first equation because those variables represent their ages now, and that's what present tense is. Okay, so Carol, excuse me, how do I translate Carol? Carol now is C, right? Is means equals twice Linda's age. And we're just going to write 2L, okay? The next sentence starts with in 6 years. So now it's not talking about their ages now, it's talking about their future ages. So in 6 years, the sum of their ages will be 30. So because we're now switching gears and talking about the future ages, we're now going to use those definitions to help us come up with their ages. So it says in 6 years, the sum of their ages will be 30. How do I translate that? Tyler B? There's a lot of pluses going on there. Absolutely. That's it. I just take their future ages, add them together, and it says that will be equal to 30. Okay? Now, according to the different ways that we've solved systems, what's going to be easy to use in this particular one? What do you guys notice that's going to really be helpful? Amy? Yeah, notice the first one was C by itself. So I'm going to take the expression that equals C, and I'm going to substitute it into the second equation. So now this is the equation I'm working with. 2L plus 6 plus L plus 6 equals 30. So I'm going to look for like terms. I get 3L plus 12 equals 30. And then I just do opposite operations. I'm going to subtract 12 from both sides. And I get 3L is equal to 18. And then I divide both sides by 3. And I get L equals 6. Now remember what L means. Linda's age now. And that's precisely what they were asking us to figure out. It's the girl's ages now. So I can already start my answer. Linda is 6 years old. I need to get a label on there. And I'm going to figure out the other gal's age. So all I'm going to do is take this and plug it into this equation. So I get C equals 2 times the L value of 6, and I get C equals 12. So I continue on with my answer, and Carol is 12 years old. Okay, and that's the problem. Now, I can always check my work. Is 12 the same as 2 times 6?
Yes.
And the answer is yes. Okay, if I add 6 to Carol's age, what does that take me to? 18. If I add 6 to Linda's age, what does that take me to? 12. Does that equal 30?
Yes.
So I can take my answers I get, plug it back into my original equations, and see if it satisfies both of them. And that can verify that I did the question right. Okay? All right, let's try a different one. We're going to add your evil little nemesis, fractions. Okay, ready? Here we go. Now, not every problem you're going to see on your homework tonight is going to look just like these. They're going to have different variations, but again, the same kind of backbone is there every time. You just have to read. Reading is so very important on these. 5 years ago, Charlie was 2/3 as old as Don. Ten years from now, he will be 5/6 as old as Don. How old is each now? So again, 5 years ago, Charlie was 2/3 as old as Don. 10 years from now, he will be 5/6 as old as Don. How old is each now? Okay, so who are my people in this one? Charlie and Don. And guess what I'm going to use as their variables? Now, even though the problem talks about their age 5 years ago and their age 10 years from now, it asks us to answer how old are they now. So that always is our first column, age now. And that's where the C and the D show up. Okay? Now, they talk about the age in the past. Age 5 years ago. So how am I going to write Charlie's age 5 years ago if he's C now? C, what am I going to write? Minus 5. And then Don would be D minus 5. Okay, and then they talk about the age 10 years from now. So I tend to write that age in 10 years. So what am I going to do to their current age to get to the 10 years from now? I'm going to add the 10 to both of them. All right, now I want to talk about another thing. So notice these are not equations. These are just definitions at the 3 different ages. Okay? So in the first equation talks about 5 years ago, Charlie was 2/3 as old as Don. Notice that it doesn't make any kind of qualifying statement about Don. So if it doesn't say as old as Don is now, or as old as Don was 12 years ago, or as old as Don will be in 10 years, the assumption is that when they're talking about Charlie and Don, they're talking about both of their ages 5 years ago. Now, I guarantee there's a question on the worksheet where they talk about one person's age in the future at the same time they talk about one person's age in the past. So you're just going to pick out those definitions of those variables from wherever you need to in the chart. But for us, they're talking about both people 5 years ago. So in the 5 years ago column, we're going to be using these definitions. So what was Charlie's age 5 years ago? C minus 5. And it says was, which is equals, 2/3 as old as Don. Ooh, how am I going to write that? That would be 2/3 as old as Don is now, but it doesn't say now. Okay, we need parentheses. Don's age and Charlie's age 5 years ago and in 10 years is a quantity. So we have to maintain the quantity by using parentheses. So that's the first equation. Okay? Second equation. 10 years from now, he will be 5/6 as old as Don. So again, they didn't say anything different about Don's age. So we're going to assume they're talking about both of them being in 10 years. So how do I write that equation? 10 years from now, he will be 5/6 as old as Don. So what do I write first? Lexi.
5, 6,
Oh, wait a second. He comes before the will be, and the will be is the equals. Who's he referring to in the 10 years from now?
Charlie.
So how do I write Charlie's age 10 years from now?
C plus 10.
There we go. Equals, and then the rest?
5, 6, and then parentheses D plus 10.
Okay, so this problem is ugly, right? I've got parentheses, all sorts. I've got fractions. So what do you think is going to be the best strategy to deal with these problems? I think we got to do some massive work here. Okay, Pratt?
Elimination.
Right now, though, elimination with fractions and parentheses, I'm not ready to get there. I still have to do some prep before I can even think about the strategy to use. Jason? I think that might be our best bet on both of these is to clear the fractions. So on the first one, there's only one denominator, 3, so I'm going to multiply everything by 3. So that top equation now becomes 3c minus 15 equals 2 times the quantity d minus 5. And since I know I can't do anything with parentheses, I'm going to go ahead and distribute. So I get 3c minus 15 equals 2d minus 10. Okay? So I'm going to temporarily leave that guy, and I'm going to go look at the second equation. How am I going to clear the fractions from the second equation? What am I going to multiply by?
6.
Yeah, so I'm going to multiply everything by 6. So then that new equation becomes 6c plus 60 equals 5 times the quantity d plus 10, which gives me 6c plus 60 equals 5d plus 50. So I'm thinking if we try to solve for one variable, we're just going to create a massive amount of fractions. So I don't think that's really the best choice. And honestly, I don't think we can eliminate the way that it's written. So what could I do to prep both equations so that I could try elimination? Justin?
Divide the bottom one by -2.
I'm not going to divide by -2 because then that's going to create a fraction. How am I going to prepare these to try to use elimination?
Multiply the bottom one by -1.
Oh, you guys are missing the basic stuff here. Dane?
Distribute 5 to D and 10.
I already did that. 5d plus 50?
Oh.
Yeah, I already did that. Emily L?
Multiply the 3c1 by -2.
Okay, well, all right. You guys are totally missing. All right, this is it. Sydney, save me.
Get the variables on one side.
And?
Them lined up like this.
Okay. So I'm going to bring the variables together on one side. What's going to go on the other side? called the constant. Yes, the constant will go there. Yeah, let's prep it to look like standard form because that's how we do elimination best. So on this one, oops, I'm going to go ahead and subtract 2d from both sides, and I'm going to add 15 from both sides. So this gives me 3c minus 2d equals 5. Over here, I'm going to subtract 5d from both sides and 6d from both sides. So that gives me 6c minus 5d equals negative 10. So I'm going to bring them both at the same level. 3c minus 2d equals 5. At this point now, it might become a little bit more clear what's the best path to take in order to solve the system. Okay? Mr. B, you've been answering questions left and right. Let's ask Donovan. What would be the best next step in trying to solve this system? I can't just add the equations together and eliminate anything. I don't have any matching coefficients with opposite signs.
I would times the bottom one by -2.
And that's what I would do as well. Good job. So I'm going to multiply the bottom one by -2 because I need my coefficients to have opposite signs, and this is the least amount of work it's going to take. So I get negative 6c plus 4d equals negative 10, and then I'll rewrite the other equation, which is 6c minus 5d equals negative 10. So now I can add the equations and eliminate the c's. I get negative d equals negative 20, and I divide by negative 1, and I get, bam, d equals 20. Okay? Now here's the killer part that people don't like, but what we're going to do is take that answer and plug it back into either original equation. If I plug it into a simplified equation and I made a mistake, then I won't catch my error. So I'm going to go back to the original equation. So I'm actually going to take this and I'm going to plug it in to this equation here. So c minus 5 equals 2/3 times the quantity 20 minus 5. So c minus 5 equals 2/3 times 15. 3 goes into 15 5 times. C minus 5 is 2 times 5, or 10. And I add 5 to both sides. Oops, 5. And I get C equals 15. So according to this, I get Dawn is 20 years old. And Charlie is 15 years old. So I'm going to clear away the chart for just a second.
Please excuse this interruption. Due to a transportation issue, at this time, please release the 8th grade boys basketball team and both girls volleyball teams at the...
So here's what we can do. We can take those ages and test them out. 5 years ago, how old was Charlie 5 years ago if he's 15 now? He'd be 10. Okay, so let me get green. So 10 was 2/3, and if Dawn is 20, how old would he have been 15 years ago? If he's 20 now, how old was he 15 years or 5 years ago? So 3 goes into 15 5 times, and I get 10 equals 10. So it holds true for the first idea. Second idea, 10 years from now, Charlie. So if Charlie is 15 now, how old will he be in 10 years? 25. And we want to know, is that going to be 5, 6, as old as Dawn? Now, Dawn now is 20. How old would he be in 10 years? 30. And I get... oh, a second, that's a 5. And I get 25 equals 25. So what I've just done is verified that these have to be the correct answer. Okay?